This video is an introduction to proofs with segments and angles. In geometry, we don't assume something to be true just because it looks like it might be true. We prove it in a logical, step-by-step manner using reasons that we already know to be true. Let's take a look at two examples. My first one is a segment proof. It says prove that if segment AB is equal in length to segment CD, then the length of segment AC is equal to the length of segment BD. Now it might be kind of obvious, you can just kind of look at that and go, well yeah, I can see how that makes sense, but we actually have to prove it step by step and back everything up with reasons. So we're going to start by stating the given. What's the given information? What do we already know? And that's generally going to be what's listed right after the word if. So it's given that AB is equal to CD. And then what we have to prove is generally written after the word then. We need to prove that AC is equal to BD. Now there are many different ways to do a proof. You can do a paragraph proof where you just write out sentences. You can do a flow proof where you draw little boxes and arrows. One thing leads to the next. Probably the most common is a two-column proof. So that's what I'm going to show you here, but if you'd like to do it another way, you're welcome to do that. Now our first statement is always the given information. So my first statement is going to be that AB is equal to CD, and my reason for that is that it is given. Okay, now it gets a little more complicated. Now we need to figure out kind of what comes next. Well, let's take a look at where we're going. So I'm trying to show that segment AC is equal in length to segment BD. And I notice that actually segment BC here in the middle is a part of each of those larger segments. So what if I were to take BC and add it to each side of the equation I have in statement number 1 here? So I have AB over here, and what if I added BC to that? And then over here I have CD, what if I add BC to that? And I can absolutely do that because I'm just adding the same thing to both sides. That's called the addition property, and we'll take a look at a list of properties at the end of this video. So the addition property says that I can add the same thing to both sides of the equal sign, which I did. I added BC. Now looking at the diagram, I notice that segment AC is made up of AB and BC. And if you remember from a previous video, that's actually the segment addition postulate that says that two smaller segments that are right next to each other, so AB plus BC is equal to AC. So AB plus BC equals AC. And on the other side, BC plus CD is equal to BD. And that's segment addition postulate. Now I'm going to abbreviate a little bit here. Okay. So now now's a good time to take a look at where I'm going. I've got to get to AC equals BD. Well, I have an expression here for AC. I know that AC is equal to AB plus BC. I know that BD is equal to this, and I know that these two are equal to each other. So instead of saying AB plus BC, in step 2 here, I'm going to call that AC. And going back to step 2, instead of saying BC plus CD, I'm going to use this and say that that's equal to BD, which is where I had to get to. And all I did there was I substituted. So I used the substitution property. Okay, that's how to do a segment proof. Let's take a quick look at an angle proof, which is kind of similar. So here we have a diagram. It says prove that if angle ABE and angle DBC are right angles, then angle ABD, which would be this one right here, is equal, the measure of angle ABD is equal to the measure of angle EBC. So this is kind of like the other one, but a little bit in reverse. Here we're given a larger angle, ABE, is equal to DBC, and I have that they share this common piece here, but I need to take it away in order to get those two smaller ones. So let's go ahead and start this. Let's do the easy stuff first. Let's just write our given, and remember that's what follows if ABE and DBC are right angles. And what I need to prove is that the measure of angle ABD is equal to the measure of angle EBC. So I'm going to go ahead and start with the two-column proof here. My first statement is my given. So those are, I'm going to start abbreviating here, right angles, and that is given. Okay. Now I'm noticing that, well, let's see, so they're both right angles, so they both measure 90 degrees, so they must be equal to each other in measure. So I can say that the measure of angle ABE equals the measure of angle DBC, and that's because all right angles are congruent. That's a little symbol for congruent. Okay. Also, from looking at the diagram, I know that angle ABE is made up of two smaller angles, so I'm going to go ahead and state that. So the measure of angle ABE is equal to the measure of angle ABD plus the measure of angle DBE. Okay, that's those two angles right there. And then I can say the other thing for big angle DBC. The measure of angle DBC is equal to the measure of the two smaller angles DBE plus EBC. And that is angle addition postulate, which basically says if you have two angles right next to each other, two angles added together equal the larger angle. Now as I scroll down, I'm going to lose my picture, but I don't think I need my picture anymore here. Okay, so what I'm noticing here is that ABD and DBE, and here I have DBE and EBC, they both have this DBE in it. Also, I have, actually before I get to that, I think what I'm going to do is a little substitution here. I'm going to take this expression right here. I'm going to go ahead and circle that. And I'm going to substitute it in for that. I'm going to take this expression right here, and I'm going to substitute it in for that. So I can say the measure of angle ABD plus the measure of angle DBE is equal to the measure of angle DBE plus the measure of angle EBC. I know it seems a little tedious, but we do need to write it all out. Okay, all I did there was a substitution, which is really cool. Okay, and I'm going to scroll back up here to see where am I going? What am I trying to get to? I'm trying to get to ABD is equal to EBC, and I think I'm very close, because notice that if I were to subtract out DBE from both sides of this, I would have the measure of angle ABD equals the measure of angle EBC, and what I did there was I used the subtraction property, which says that I can subtract the same thing from both sides of an equation. Okay, one thing I would say here is be careful, don't just use SUB as an abbreviation because we don't know if it's subtraction or substitution. So there's an example of an angle proof. One more thing I'd like to take a look at here is, okay, you'll notice that all of the things that I used as reasons, a lot of those were definitions or theorems or postulates that we saw in the vocabulary exploration activity, and then also a few things that I added at the end of that topic 1 video. You should also be familiar with the following properties, and these are properties of real numbers, which means that they actually apply to numbers, but they can also apply to angles and segments as well. So you saw that we used the addition property of equality, which says I can add the same thing to both sides of an equation. Subtraction, same idea, subtract the same thing. Multiplication, division, we didn't see that, but you're familiar with that. Here's a couple strange ones. The reflexive property says that anything is equal to itself. We'll see that when we get into topic 4 and start to talk about triangles. The symmetric property of equality allows me to flip things over the equal sign. Transitive property says that if A is equal to B and B is equal to C, then A is equal to C. You saw that we used the substitution property. If A equals B, then A can replace B in anywhere. And then there's the distributive property. To be honest, that doesn't come up a whole lot in geometric proofs, but I thought I'd throw it in there for you. So as I said, these do apply to the set of real numbers, but they also apply to the measures of segments and angles. So here's an example of the substitution property as it applies to each of those. So if I were to use the substitution property for real numbers, I can say if 3 plus 5 equals 8 and 2 plus 6 equals 8, well, they both equal 8, so they equal each other. So 3 plus 5 equals 2 plus 6. We saw a little bit of this in segments. If AC is equal to DF, and if this is what AC is, I can plug it into there. If this is what DF is, I can plug it into there. So then I can when I do that substitution, I have that AB plus BC equals DE plus EF. Same thing with angles. If angle A is equal to angle B, and angle A is 1 plus 2, and angle B is 3 plus 4, then I substitute 1 plus 2 for A and 3 plus 4 for B. So in this video, we took a look at how to do some basic proofs with segments and angles. The main idea being that sometimes we need to prove things in geometry, and you can't say that something is true just because it looks like it. You actually have to give some solid reasons, back it up with theorems, postulates, definitions, and properties, and we went through what some of those are. So in the unit application, you'll get a chance to try a couple of these on your own.